Dear listeners, I will calculate the energy of the electron in a hydrogen atom. The electron revolves around the proton. We denote the mass of the electron by m, speed of the electron v, and radius of the circular orbit by r. The necessary centripetal force mv square by r is provided by the electrostatic force on the electron F equal to 1 by 4 pi epsilon naught E square by R square. Therefore, mv square by r equal to 1 by 4 pi epsilon naught E square by r square, and v square equal to 1 by 4 pi epsilon naught E square by mr. From classical mechanics, we know that an accelerating charged particle radiates electromagnetic waves. So the electron must lose energy during its revolution, and then the atom should collapse. But the atom does exist. Niels Bohr overcomes the problems. Bohr says the electron must revolve in some permitted orbits. The permitted orbits are as such that their length must be the integral number of wavelengths of matter waves associated with the electron such that a stationary matter waves is produced. Then the electron energy is confined in the orbit and it will never go out. Therefore, the electron energy remains constant. According to Bohr's theory, the length of the orbit twice pi r equal to n lambda. Lambda is the wavelength of matter wave of the electron. N is an integer 1, 2, 3, etc. Or twice pi r equal to lambda n lambda equal to h by p. Therefore, pr equal to n h by 2 pi. P equal to mv. Therefore, mvr equal to n h by 2 pi. This is the second form of Bohr's theory, from which we may write V equal to nh by twice pi mr. Putting this value of V in equation number 1, we get n square h square divided by 4 pi square mr square equal to 1 by 4 pi epsilon naught E square by mr, from which we can calculate r. R equal to epsilon naught h square n square divided by pi e square m. The total energy of the electron E equal to half mv square kinetic energy plus potential energy minus E square by 4 pi epsilon naught r equal to half m b square equal to 1 by 4 pi epsilon naught from equation 1 E square by mr minus E square by 4 pi epsilon naught r, which is finally minus m e to the power 4 divided by 8 epsilon naught square h square 1 by n square. This is the energy of the electron in nth orbit. Therefore, it is En. En equal to this. Putting the value of R from equation 2, N is called the principal quantum number. Therefore, E1 equal to N equal to 1, then the energy of the first orbit, first shell is minus m e to the power 4 divided by 8 epsilon naught square h square. This is 1. And it is calculated as minus 13.6 electron volt, where 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. From equation 2, we have En equal to E1 divided by n square. Knowing the value of E1 minus 13.6 electron volt, we may find E2, E3, E4, etc. E1 is minus 13.6 electron volt, then E2 is minus 3.4 electron volt, E3 is minus 1.5 electron volt, E4 minus 0.85 electron volt. E1 is called ground state energy. The potential energy of the orbiting electron EP equal to minus E square by 4 pi epsilon naught r, which is negative. The negative potential energy exists in any other particle in any attractive field. The kinetic energy of the orbital electron Ek equal to minus E square by 8 pi epsilon naught r, which is minus half into E square by 4 pi epsilon naught r, that is half of EP. Sorry. Kinetic energy is positive. It is positive. E square by 8 pi epsilon naught r. It is positive. That is half of modulus of potential energy. Kinetic energy is equal to half of the modulus of potential energy. So the total energy is negative. Thus, the energy of any atomic orbital electron is negative. The electron closest to the nucleus, that corresponds to the quantum number 1, n equal to 1, has the lowest energy called the ground state energy. It is the most negative energy among all other states. If the total energy of an orbital electron be negative, then we may say that the electron is bound to the nucleus. If the total energy be 0, then we may say that the electron is no longer bound to the nucleus. It is a free electron. Thank you.